Hello, I'm Bobby Hensley. I'm an aquatic biogeochemist on the NEON Aquatic Sciences team, and I'm going to be giving you a brief overview of the NEON Aquatics program. As you know, NEON is an NSF-funded network of monitoring sites across the continental US, Alaska, Hawaii, and Puerto Rico. NEON is designed to collect long-term open access ecological data to better understand drivers of ecological change. The NEON network consists of 34 freshwater aquatic field sites. 24 of these are wadable streams, 3 are rivers, and 7 are lakes. There are 20 of what we term core sites, 1 for each domain with the exception of D3, the southeast, which has 2, and then D20, Hawaii, has none. There's also 14 relocatable sites, and these are designed to provide comparisons with the core sites. For example, along hydrologic gradients or across hydrologic divides. It was initially planned that the core sites would remain in place for the life of the 30 years of the observatory, while the relocatable sites would move in response to different user needs. But this idea has somewhat been backed off from for budgetary reasons. Here's just some cartoons of the general layout of the different types of sites within the NEON network. Because NEON is intended to both track long-term change within sites and to enable comparisons across sites, everything is standardized as much as possible. NEON sampling has 2 components: instrument sampling, or IS, and observational sampling, or OS. And where both of these modes of sampling occurs varies slightly depending on constraints dictated by the site type. So wadable stream sites, river sites, and lake sites are set up a little bit different, as you can see on the cartoon there. Here's an overview of how the IS sampling instrumentation varies by sites. So stream sites, which are the most common, are instrumented at both an upstream and a downstream station. At both stations, we measure water level, temperature, water quality, including specific conductance, dissolved oxygen, pH, turbidity, and chlorophyll. And then we also measure fluorescent dissolved organic matter, but only at the downstream station. And then in situ nitrate measurements are also made, but only at the downstream station. There's between 4 and 6 groundwater wells for each stream site, which measure groundwater elevation, temperature, and conductivity. There's also an onshore MET station. This is sort of a scaled down version of the towers that they have at our terrestrial sites. And there they measure temperature, pressure, humidity, wind speed, and direction. For the most part, river and lake sites are instrumented more or less in the same way, the only difference being that there's just one set of measurements that are taken from a buoy that's moored in the deepest part of the lake for lake sites, and then as close to the thalweg of river sites as is possible without impeding navigation. Here's a little bit about instrument sampling frequencies. For our aquatic instruments, you can see that the sampling frequency for most of them is quite high, usually between 1 and 5 minute intervals. We also provide average data to reduce sensor noise. You can see here are values for surface waters, elevation measured at 1 minute, 5 and 30 minute averages, temperature also measured at 1 minute, and then 5 and 30 minute averages. For our stream sites and the surface of the river and lake sites, we use a platinum resistance thermistor. And then the lake and river sites also have a temperature chain that continuously measures temperature at discrete depth intervals. Water quality, those were the parameters I talked about in the previous slide. For streams, those are measured every minute at both the upstream and downstream location. And then for lakes, these parameters are measured every 5 minutes at the surface, and then every 4 hours, a depth profile will be collected, measuring those parameters at various depths within the water column. And then nitrate at 15-minute intervals. You can see on the right is sort of an example of instrumentation at a typical stream site on the top, and then there's a lake buoy there on the bottom. Here's some more information for some of our meteorological and groundwater instrumentation. So some of the things that are measured, 2D wind speed and direction, air temperature and pressure, humidity, and then both shortwave, long wave radiation and photosynthetically active radiation. There's a picture of sort of our scaled down met station at the top for our aquatic sites. And then on the bottom is a picture of one of our groundwater wells where we measure groundwater elevation, temperature, and specific conductance. Here's a list of the observational sampling that's performed. It's a rather long list, and as I only have 8 minutes, I don't have time to go into all of these. I'll leave it up there for a second for everyone to just skim through though. Some of the major ones are biological sampling of things like plants and algae, macroinvertebrates, and fish. This includes biomass, species richness, and then genetic barcoding. And then some of the physical sampling, things like riparian habitat assessment, lake bathymetry, and stream channel morphology. Here's some of the frequencies for our OS sampling. Most of the biological sampling is done between 1 to 3 times per year, whereas some of the more physical measurements like morphology and bathymetry are only done once every 5 years or so, with the exception of stream sites. If they do have a large flood that causes scouring and causes the morphology to change, then we will go back and do another survey. As far as data latency for most of the IS, the instrument sampling, at the end of the day, all of those measurements get streamed back to our headquarters in Boulder, where they get compiled and QA/QC is done, and then they are posted on the data portal on the first Monday of every month. So that turnaround is relatively quick. The latency for the OS data is a bit longer because it's not all automated. Typically, it can be anywhere from 2 to 4 months before OS data get published. So I have 30 seconds left. I'd just like to say I hope I get a chance to meet most of you over the next 2 days of the meeting and discuss in more detail any of your individual questions and your data needs. If for some reason we don't get a chance to talk, here's my email address. Please feel free to reach out to me with any questions you have. And thank you for listening.